Hi everybody and welcome back to my channel. AudioKeller is proud to present another amp dyno video of a classic car audio amplifier. This time I had the Rodek R2180i on the bench. First I had some issues with the RCA inputs and sorted a new one in. This amp is also subscriber supported. Thank you very much for sending in amplifiers. What I like about the amplifier is it has big connectors for battery plus and grounds. The amplifier is rated 2 times 180 watts and it has a good efficiency, so I decided to do a dynamic power test into a 2 ohms mono load. The amplifier features a low pass filter, a high pass filter and a full frequency spectrum switch, and the frequencies range is from 50 Hz to 250 Hz. The Rodek also features a subsonic filter which is adjustable from 13 to 185 Hz to protect your subwoofer from over-excursion. The Rodek amplifier is connected to the dummy load, and as usual I start with 8 ohms mono connected to the amplifier, bridged mono. That means I test 4 ohms per channel, both channels driven. Continuous power test with 1 kHz into a 4 ohm load per channel, both channels driven. And we are at 74.8 volts. The amplifier delivers an output power of 179.3 watts. Now let's have a look how many amps the amplifier pulls. And it's 40.2 amps. The amplifier has an efficiency of 65.6%, 50 Hz. Looks clean. It says maximum voltage 76.8 volts. That's more than with 1 kHz. I'm a little bit surprised. And we really have a peak voltage of 76 volts. The amplifier delivers around 185 watts into a 4 ohm load per channel, both channels driven into full power with 50 Hz. Now I'm hunting for some dynamic power. That means 20 cycles, 1 kHz. So let's have a look at the last cycle. I would say this is clip free. I can confirm 79.2 volts. 20 cycles of dynamic power. The amplifier delivers 201 watts. And dynamic power test with 8 cycles. We have a maximum voltage of 78 volts. The amplifier delivers 195 watts into a 4 ohm load per channel, both channels driven. 1 millisecond burst. It says 79.2 volts. The amplifier delivers 201 watts. Dynamic power with 50 Hz and 5 cycles, that means 100 milliseconds. Let's have a look. Maximum voltage 78 volts. Let's check out the other cycles. It says 79.2. I take the lowest cycles. So we are at 75 volts. The amplifier delivers 180.3 watts. 10 cycles, that means I have an input signal of 200 milliseconds. We have 78 volts. That's true for the first cycle, but let's go deeper to the others. We have 75 volts. The amplifier delivers also 180.3 watts. Now I switch to 4 ohms mono. That means I test 2 ohms per channel, both channels driven. Continuous power test into a 2 ohm load per channel. There it is. It says maximum voltage 72 volts. I go to the top. Let's say 70.8 volts. Good power into 2 ohms. The amplifier delivers 321.4 watts. Let's have a look how many amps the amplifier is pulling. Wow, 71.3 amps. I calculated an efficiency of around 66%. Continuous power test with 50 Hz. Oops. Reducing input signal. Looks good. We have 70.8 volts. That's impressive and not bad. The amplifier delivers also 321.4 watts into a 2 ohm load per channel, both channels driven into full power. Dynamic power 20 cycles. It says 73.2 volts. Let's be fair and calculate with 72.6 volts. The amp delivers around 338 watts of dynamic power with 20 cycles. 8 cycles, 1 kHz dynamic power. We have 73.2 volts. Yes, I can confirm this. And we have no clipping. With 8 cycles, the amplifier delivers 343.5 watts into a 2 ohm load per channel, both channels driven. 1 millisecond power 2 ohms, 1 kHz. Let's go with 75.6 volts. For just 1 millisecond, the amplifier delivers 366.4 watts into 2 ohms. The amplifier still has a nice efficiency of more than 60%, so I'm going to make a 2 ohms mono test. 2 ohms mono is connected to the amplifier, and I will start with a very soft test with a 1 millisecond burst, and then I go to 8 milliseconds and 20 if possible. 1 cycle. Very dirty. I go back and reduce the input signal. But that looks really okay. And not too bad. It says 60 volts. And we have 60 volts. 450 watts for 1 millisecond with 1 kilohertz into a 1 ohm load per channel. 8 millisecond burst power test. And let's have a look at the last cycle. Distorted. I reduce input signal until we have almost distortion free output power. Let's have a look at this. This is not too bad, but not very clean. We have an output voltage of 55.8 volts. The amplifier delivers 389.3 watts. And we have a maximum voltage of 55.2 volts. Looks not too bad. Let's say 53.4 volts. With 20 cycles, the amplifier delivers into a 1 ohm load 356.5 watts. That's 713 watts into 2 ohms mono. Now I try to squeeze out a little bit more output power. I am on the last cycles and now I get really dirty. It's still not clean. Okay, this is what we can take now, and we are at 56.4 volts. After the fine adjustment, I got some more watts out of the amplifier. I have 397.7 watts into a 1 ohm load. That means 795.4 watts, 2 ohms mono. Here's a picture with all 20 cycles, almost at the same voltage level, and it says the high cycle 57.6, that's somewhere here, and the first is a little bit lower, so I was fair. Take the average of 56.4 volts is fair and not bullshitting, and you can see there's no clip. 67.8 volts, 321.4 watts. Now I'm testing with 10 cycles, 67.8. With 10 cycles the amplifier delivers 294 watts on the lowest cycle and 321.4 watts at the highest cycle. Thank you very much for watching and see you next time for another Amp Dyno video. Bye bye.